Hi everyone, welcome back to my channel. My name is Tariq Jabir. I'm a student at LFP, and today I'm going to be teaching you about galaxies. Alright, so what are galaxies? Galaxy is a chocolate bar that was first manufactured in the United Kingdom in the 1960s. Now, that was hilarious. Did you guys see this guy? Galaxies, galaxy, not original, hilarious. Alright, I'm sorry. But seriously, galaxies are the building blocks of the universe. They are vast cosmic islands of anywhere between hundreds of millions to even trillions of stars, along with dust, gas, and dark matter. Galaxies vary in shapes and sizes and can be grouped in small groups or even immense clusters. Now, believe it or not, this whole idea of galaxies is actually a very recent idea. In fact, up until the 30th of December 1924, astronomers believed that our galaxy, the Milky Way, was the whole entire universe. But on that day, an observation made by the Hubble Space Telescope of the Andromeda Galaxy, our neighbor galaxy, gave us clear evidence that our Milky Way is very far from being the whole universe and is also very far from being the only galaxy in the universe. We're going to talk about three main things in this video. First one being how galaxies are formed, and then the different types of galaxies, and finally we're going to see how galaxies are grouped. So, how are galaxies formed? Well, while astronomers aren't yet 100% sure of how they formed, they do have some ideas about their origin and how they evolved. Now, obviously, a human lifespan is not long enough, not nearly long enough, to watch a galaxy form and grow. But using very big telescopes and supercomputers, astronomers can look deep into space, which, because light needs time to get to us, is equivalent to looking back in time. And by doing that, astronomers can observe different stages of galactic evolution and have an idea of how they form and evolve. You can think of it this way: if you point a camera at a person for 10 minutes, you're not going to have a single idea about human evolution. But if you look at different people around the world, a person that's 2 years old, another that's 10, one that's 15, 20, 30, 40, 80, you can have an idea about how humans evolve. Astronomers did exactly that and found that galaxies formed fairly soon in the universe, so around 300,000 years after the Big Bang, when the whole universe was filled with mainly hydrogen and helium, with some areas denser than others. Gravity caused these dense areas to collapse into clumps or clouds of gas, start nuclear fusion, and start the first generation of stars. Gravity would then even cause multiple clouds to themselves collapse into each other, forming bigger clouds, accumulating eventually to becoming rotating disks. So, after forming, galaxies evolved to have more stars and more defined shapes, as we can see in this picture. Astronomers also discovered that in the center of most large galaxies exists a supermassive black hole. Now moving on to the different types of galaxies. Astronomers classify galaxies in three main categories: irregular, elliptical, and spiral galaxies. Now, before we dive into the details of each of the categories, we need to define the units we're going to be using to describe these big distances. The first one is the light year, which is equivalent to around 9.5 times 10 to the power of 12 kilometers. The other one is the parsec, which is equivalent to approximately 3.3 light years. And the final one is the megaparsec, which is 1,000,000 parsecs. So let's start with elliptical galaxies. Here are some pictures. Elliptical galaxies vary from nearly circular to very elongated. These types of galaxies are not as active anymore, meaning that they're not forming as many stars as they used to. The biggest elliptical galaxies are called, well, giant ellipticals, and they measure about 300,000 light years, or about 90,000 parsecs in diameter. The smaller and more common ones are called dwarf ellipticals and only have a diameter of a few thousand light years. Now we move on to spiral galaxies, like our Milky Way, and here are some pictures of some others. Spiral galaxies fall into two main subcategories: barred spiral galaxies and normal spiral galaxies. Both these subcategories are pretty similar. The only difference is that barred spiral galaxies have a bar going through the center of the galaxy, while normal spiral galaxies don't. The third and last main category of galaxies are irregular galaxies. These galaxies have very little dust and are not disc-shaped nor elliptical, but, as their name states, irregular. They don't really have a certain shape or size. Now, most of the observed irregular galaxies were observed deep into the universe, far from us, which, as we said earlier, is equivalent to looking back in time. Now, this tells us that these types of galaxies were abundant in the early universe and appeared before elliptical and spiral galaxies did. So those are the three main categories of galaxies: spiral galaxies, elliptical galaxies, and irregular galaxies. Galaxies, despite being very, very far from each other, still form groups called clusters. For example, our galaxy, the Milky Way, the Andromeda Galaxy, the Large Magellanic Cloud, and the Small Magellanic Cloud are all part of a cluster called the local group. Now, there are two types of clusters: poor clusters and rich clusters. Poor clusters measure only about 1 megaparsec across and have about 1,000 galaxies, while rich clusters measure 3 to 10 megaparsecs across and have thousands and thousands of galaxies in them. An example of a rich cluster is the Virgo cluster, measuring about 3 megaparsecs across, having over 2,000 galaxies, and being over 15 megaparsecs away from us. Now, clusters are themselves clustered to form bigger clusters called superclusters. These superclusters measure about 100 megaparsecs across. They are the largest known structures in our universe today. There are about 10 million of these superclusters in the observable universe. An example of a supercluster that both the local group and the Virgo cluster are part of is the local supercluster, measuring about 50 megaparsecs across. It is also important to mention that despite the accelerating expansion of our universe, galaxies can collide with one another. In fact, it is the case with our Milky Way and our neighbor, the Andromeda Galaxy. We will collide with this nearby galaxy in about 4 billion years. This collision, the result of mutual gravitational attraction between the stars, planets, and other matter that make up both galaxies, will produce a single merged galaxy. It is unlikely that any stars of either galaxies will actually collide due to the great distances between them. But some stars will likely be ejected from either galaxies during the collision. So to conclude, galaxies are formed around 300,000 years after the Big Bang, when gravity collapsed multiple clouds into each other to form rotating disks. There are three main types of galaxies: spiral galaxies, elliptical galaxies, and irregular galaxies. Galaxies are grouped in groups called clusters, and clusters are themselves grouped to form superclusters. And those are the biggest known structures in the universe. Thank you all so much for watching. I hope you're enjoying this content. If you are, please like the video and subscribe to my channel. It means a lot. I'll catch you guys on the next one.